Alright, today's lecture we're going to talk about angles and triangles. Uh, Try to get through this one as quick as I can, as usual. Probably because my iPad's about ready to die. Anyway, uh, probably the best way of doing this to save time is pause the video right here and copy down these facts about triangles. I'm not going to read them off. So go ahead and do that. Okay, that was cool that I figured that out. What we're going to do is, one thing in geometry I want you to know how to do is actually how to write a proof or come up with a proof. This is the first one that we've had. So I'll go ahead and read this to you. We want to show that the sum of the angles in a triangle, okay, I'm just kind of abbreviating here, a triangle is 180 degrees. Now, in order to write a proof, you got to keep things as general as possible, and that's one thing I really learned how to do this past summer. So what I'm going to do is, obviously, can't really assume anything, but I'm going to draw a triangle. All right. Now, inside this triangle, we have three angles. Okay, so we can't say that the three angles are supplementary. It's because supplementary is when you got two angles that equal 180 degrees. But nonetheless, these three angles add up to be 180 degrees. And what I'm going to do is I'm going to name these angles something different. Okay? Because I don't know what they are. They're kind of like variables, but they're Greek. The one I just drew there in the orange is called theta. And I can write that out to the side. When we say theta, you're going to see that symbol a lot. The next one, I'm just going to give it another cool Greek symbol. That's called alpha. And these would make great video quizzes for tomorrow. The last one is, I can't draw very well, it's basically a B, and we're going to call that beta. Okay? So I wrote that out for you. We can't just say, oh, I'm going to make this angle this measure and this one this measure. No, we got to keep everything general. That's what a proof is all about. So what I'm going to do to show my proof is I'm going to use basic facts and information. I may have to erase this out to the side now that you've been able to copy that down. Don't you erase it. Keep it somewhere. But I'm going to need it to make a little bit of room. Guys, I'm going to use basic information, facts, definition. That way I can show my proof. Okay? We know, alright, we know that a straight line is 180 degrees. And I'm going to use that fact in my proof. Okay? So what I'm going to do is I'm going to extend some lines here. I want to make this parallel as much as I can. You guys would be better at this than I would. Now I'm going to run a parallel line through the top of my triangle here. Okay? We're going to say that this bottom line, I'm going to erase my general fact over here, because we know that a straight line is 180. We got a line right here that's parallel with this guy right here. Okay? And we've already learned some postulates and theorems about parallel lines and a transversal. And I'm going to utilize that in my proof. Okay? Pretty simple proof, really. As I'm going along here, I'm going to use theta. I'm just going to keep it right there, really, honestly. All right. the line that's going across the top of my triangle, this line right here that I just highlighted, that's the line I want to use to show that since that's a straight line, all three angles are going to add up to form that straight line. Now, I'm going to undo here and change colors. Now, let's look at alpha for a second. This guy right here. Alright, I'm going to erase everything else, just for the time being, and show you what I got going on and how I can use this theorem. If you remember from previous video, we have alternate interior angles. Alright, now if I go across the transversal here and get to this angle here, okay, by that theorem, the alternate interior angle theorem, I'm inside the parallel lines. I have a congruent, that's an ugly looking alpha, okay, I have a congruent angle there, okay, and you might even have to ignore this line right here to really see it, okay. So there's the alternate interior angle theorem. Now I'm going to put everything back in its place and finish it out because we're just about there. So I got theta here, beta was down here. Now at the same token, all right, I'm going to use the alternate interior angle theorem that we have and figure out beta. Well, where would beta be in this? Okay, if I jump over that transversal, that part of the triangle, okay, and then bring it up in here, well, there's beta. Now, if we look at all three angles put together, what did we just form? All three of those are going to form that straight line. And we just talked about earlier that a straight line is 180 degrees. That's a given fact. Okay, and we use that fact to prove a new fact. So I got alpha plus theta plus beta. That equals 180 degrees. And I like to end my proofs with the little fancy box. Like, I'm done. All right. That might be some type of question on the test or a compare and contrast. And be creative. See if you can come up with a different method of showing that there are 180 degrees in a triangle. Now let's look at some examples. We're going to use some definition of facts. Now that we proved that there are 180 degrees in a triangle, we're going to use that to solve some problems. Let's look at problem 1 here. We got to find x and then the missing angle measures. Now one thing's for certain, they gave us one angle, and I'm highlighting it right now in purple. That's 90 degrees. Now what I'm going to do is I'm going to set up an equation, something you guys are going to have to get used to and get good at. We know that the sum of all these three angles in the triangle is going to equal 180. Well, let's list what we're given. Well, we got x plus 5, so I'm going to write x plus 5 degrees, plus, we got an angle here, 2x minus 2, plus, what's this guy right here? Okay, now, I can combine like terms. Remember, if there's not one there, put one there. We got terms on the same side. We just need to put together. Just add them together. 1x plus 2x, 3x. And then we have positive 5 minus 2 plus 90. I'm looking at positive 2 or positive 5 minus 2. That's positive 3 plus 90 plus 93 equals 180. Now we got a two-step equation. And I know you guys are good at these now. You've had it for the past 4 years. 3 years anyway. Alright. Let me get my calculator. I was messing up the other day in class. I don't know what was going on in my brain. So we have 87. I could have done that in my head. I don't know why I didn't. And then bring down to 3x. Guys, this is the part where algebra meets geometry. Okay? Geometry is definitions and facts about shapes and spatial sense. And we use formulas to change it into an algebraic problem. Now I got my x. Now I got to figure out my angle measures. Okay? Well, what's this angle measure? 2x minus 2. Well, let's punch in 2 times x, which is parentheses 29, minus 2. So I'm going to punch that in. 2 times 29 minus 2. This angle is 56 degrees. I hope so. So we found that angle measure. Now let's go to the other one. This one's just x plus 5. Well, I'm going to plug in 29 plus 5, which is 34. Now I should be able to add all three of these angles and get to 180. So if I took 34, I'm going to highlight in pink here, 34 plus 56, okay, that's 90. Plus we already have a right angle, which is 90 degrees. That equals 180.